So we will move to the next speaker and the first male speaker of our conference. So we welcome Demian with a lot of pleasure. So
thanks for the invitation. Can you hear me?
Yes, we can hear you.
Okay, let me share. Yes, and now you should see the slide, isn't it?
Yes, we can see your slides. So yeah, it's our great pleasure to have you here. Unfortunately, you could not join in person. I hope next time you will be at KAUST with us to share your findings. And when you're ready, you can start.
Especially after your president told us that it's very warm. Here it's -5. So it's an important difference. Thanks for the invitation. And thanks also for accepting one of the rare male speakers in this conference. So actually, let's start, as many other speakers before me, with a short presentation of who am I. So actually, I'm not really an expert of gender bias and gender inequality. As a matter of fact, I was trained as a physicist with interdisciplinary skills in computer science. And more recently, in the more recent years, I moved toward neurobiology and the simulation of brain circuits. So I am what one could call a theoretical neuroscientist, and I am a complex system scientist. So actually, also, I'm not a woman. I'm not a woman, of course. I'm a man. I'm the first male speaker in the conference, and so I am father of 2 kids, Pierre, 12 years, and Thomas, 9 years. You can see here a nice picture. And actually, I am also a member of a family of researchers and scientists, because my wife is also a scientist. Actually, she's an associate professor of European literature. So, and I will not enter in the details of my biography, but I think that just as a small teaching that you can receive from the men who did experience probably the bias and the difficulties that you experience as women, actually our life of scientists and of a scientist family has been quite complex, with a lot of movement through various cities. So actually, and interestingly, it has also been symmetric. So there have been situations in which I have been following my wife, my partner, and situations in which my partner have been following me. And then this movement has become more complicated when we started having children. And that's why here you see a bit of some movement. So I moved from Trieste, where I made my PhD, to Paris, where my wife was completing her PhD. Then I got a postdoc in Göttingen, and then it was my wife following me. Then actually, when I was hired in France, we moved to France now with a kid, and then my wife was hired in Strasbourg, and then now it's my turn to move, and so on and so forth. So actually, that's just interesting to mention that it's possible to have a family life together with a research life where both of the partners are active scientists. This just needs and demands flexibility and availability to alternate maybe the roles about who is leading, about who has the lead now. Maybe sometimes it's me, sometimes it's my wife, and so on and so forth. Okay, but that's not what I'm going to tell you today, mostly. So my aim today is to present you some results from this research paper that we published a few years ago on the eLife journal. And this is indeed, to date, my only work in the domain of quantification, rigorous quantification of gender bias in the research system. So we have some follow-up running up now. And specifically here we focused on gender bias in scholarly peer review, which is one of the key elements of scientific production and publication. So before entering into details, I want to highlight the authors of this group. This was mostly a group of Markus Selmer, a former PhD of mine, together with 2 other colleagues, Manuel Schottorf and Andreas Neff. And please remind, since now, you will see at the end why, that we are all 4 men, males. Okay, so to realize this study, we took advantage of the public availability of data from a family of multidisciplinary journals, the Frontiers in Science journals. So Frontiers is a Swiss publisher, editor, and actually the Frontiers series of journals publish 139 different journals on a variety of different disciplines. Here you see a few of them, from earth science to aerospace engineering, aging, neuroscience, mathematics, physics. So actually there are over 1,000 individual topical specialty represented. So it's a very productive family of journals publishing since the creation in the early 2000s over 200,000 articles, and there are many different onboard editors. So I don't want to make here an advertisement to the Frontiers journal family. So actually, you may be aware, if you are familiar with the journals, that there are even potential discussions of whether one should consider this type of journals predatory or not. I don't enter into this debate. This is not interesting. I publish in these journals, and there are for sure a lot of very good articles published in these journals. One of the interesting aspects for us of these of the publication strategy of the Frontiers journal, and Frontiers was pioneering under this respect, is that together, alongside with the publication of every article, here is an example article that I published in Frontiers in Neurosciences, in addition to the list of the authors of the article, you can also find, and by the way, once again, you realize that all my co-authors were male. Together, alongside with the list of co-authors, you can also see that public information is disclosed about who was the actual associate editor who handled the organization of the peer review, and also the identity of the peer reviewers that concretely wrote the peer review and led to the acceptance of the article. So now there are many journals through different publishers that publish and disclose reviewers' identity, but at the time this was a relatively novel fact. So, and all this information is public. So the question is how to extract it. Okay, so here we have 3 levels of participation to the publication. So the first level, of course, is you have the writer authors that write the articles, you have the reviewers that review the articles, and you have the editors that appoint reviewers. These 3 levels form what one could call a hierarchical social system. Indeed, it was described as such by Bourdieu, who was one of the first sociologists to get interested into the social structure and social organization of scientific production, and its peculiarities with respect to, or its peculiarities or its homogeneity with other work hierarchical systems. So in the scholarly peer review social system, editors are the higher level. Editors appoint reviewers, and reviewers evaluate authors. So you see that the relation, the fact of appointing a reviewer or the fact of evaluating an author create relations between one level to the next. So in other words, this social hierarchical system can be described as a directed network. Every editor could be considered as a node in this network, every reviewer could be considered as another node, every author could be considered as another node, and the relations of editor appointing reviewers or reviewers evaluating authors could be considered as an edge in a graph. So this form what is called the directed network. And actually networks, and directed networks specifically, have been widely studied in a variety of different disciplinary fields. So you may have heard about if you type a complex network on Google, you will find a lot of very nice pictures and images, such as this nice diagram here, which represents the protein-protein interaction network in the yeast, in Saccharomycetes cerevisiae, or this other nice network here below, which represents the connectome, the set of connections between all the different neurons of a small organism, in this case, a worm. And actually, recently, this type of very beautiful network objects has also been the object of art exhibitions, such as this very nice picture coming from an art exhibition organized at the Center for Art and Media in Karlsruhe, which was really an art exhibition showing as artistic reproduction very nice example of networks from different disciplinary fields represented as sculptures or as beautiful objects. Okay, even most interestingly, the fact of recognizing that the peer review system is a complex network allow us, using the large variety of tools that complex network science has been shaping in order to describe the spatial organization of these networks and infer out of them precious information about the application domain. Okay, so actually, what could we do in order to analyze the structure of the peer review system? So my PhD student, Marcus, now successful researcher in Google, actually wrote a small spider program, a crawler, web crawler, in order to parse automatically the large variety of articles published by the Frontiers Journal. So we did this work between 2015 and 2016. So actually, he stopped at the moment in 2015. And actually, he parsed through this web crawler over 40,000 articles. And actually, we extracted various informations out of these small information fields here. So notably, we extracted the identity suitably anonymized of editors, reviewers, and authors. We extracted the country to which their institution belongs. We extracted the scientific discipline to which the article belonged. And through an interesting automated gender assignment algorithm, we also compiled, among various other properties, the gender of all these actors of the peer review system. And so in doing so, we gathered information for over 9,000 editors, over 43,000 reviewers, and over 100,000 authors. So our initial aim, please, I want to stress it, was not to study gender inequality. Initially, as complex system scientists used to handle network data in neuroscience, such as structural and functional connectomics, what we wanted just to do was to write a generic network science articles about any potential topological specificity of this network. Gender was not our main preoccupation from scratch. So as a matter of fact, this study could have been yet another complex network paper. But what happened inspecting this data that we naively and agnostically collected was that gender bias in this data were so pervasive, so prominent, and so evident that we experienced a real data-driven revelation or conversion to the relevance of the problem. As I told you before, we are all males. We had not in mind to study gender. Gender imposed to us as the main important aspect to study into this data set. So first, the most trivial, in a sense, the most evident aspect of gender bias and gender inequality into this dataset was the existence of a massive gender gap. This was not really a surprise, but actually this allowed us quantifying it very precisely. This allowed us quantifying this large mass of articles, allowed us quantifying very precisely how gender gap was evolving through the years. So, and also how it was different how it was different or more severe to the different hierarchical levels of the social network we're considering. So in particular, the gender gap is growing to the social hierarchy of peer reviews, being more severe for editors than for reviewers than for authors. Actually, we could even extrapolate at the current, at the observed rate, what would be the year in which the gender gap could have been closed for the different levels. So actually being 2027 for authors, 2034 for reviewers, 2042 for editors. Oh, 1 second, I just have to branch my charger. Otherwise, the computer will die. Sorry. So, so actually, we're also beyond evaluating how slow was the progression toward closing this gap. We could also evaluate heterogeneities in these gaps, for instance, to countries. Here you have a map showing, for instance, the fraction of women reviewers as an example across countries. Actually, you can see that it's not the same everywhere in the world. There are, well, you have some countries like former communist countries where you are close to 50%. You have other countries like, unfortunately, Saudi Arabia, where this gap is particularly strong. So we could also interestingly evaluate profit of the multidisciplinarity of the Frontiers journal family to study how the gender gap varied across disciplines. And you can see that you can have a substantial heterogeneity. You have disciplines such as neurorobotics, computational neuroscience, physics, mathematics, the more mathematical disciplines, where the fraction of women can be lower than 20%. But you can also have disciplines such as psychology or public health, where on the contrary, you are approaching or even slightly trespassing 50%. So gender gap is pervasive and it's heterogeneous. So a second fact that we could analyze, going more and more in detail toward the topology of this network, was the actual distribution of what is called the network degree. The network degree representing here, in this case, the number, for instance, of reviewer appointments that different subjects receive if you consider the editor to reviewer subnetwork. Actually, here you can see a distribution. The distribution is substantially fat-tailed, indicating that there is a large majority of reviewers that review very few articles, and the minority of reviewers that happen to review a large variety of articles. And actually, you can see that especially when you consider these tails, the number of women which review a lot of articles, which are very active in peer review, is definitely underrepresented below the chance level. On the contrary, there is a slight excess of men reviewing above chance level in this large tail. Actually, another interesting fact that is stressed is that is the other extreme, the one of women that or men that review very rarely, only once. Actually, there was actually an excess of women reviewing only once, meaning that not only women are probably less active in the peer review domain, happen to be less frequently appointed a large number of times, but also they are a larger fraction of times one-time reviewer, and then we forget about them. Maybe because they leave the system, one could say. Okay, but let's stress the last aspect of topological organization before launching the discussion. Actually, you remember that I stressed twice already through this talk how I happened to publish frequently with a variety of colleagues which were all men like me. I show you these two articles, and I highlighted twice this author list. So this is an example of a widespread phenomenon in social networks, which is actually called homophily. Homophily is the tendency of nodes in a network to link and to wire with nodes having similar properties. Like here, all the blue nodes with the blue nodes and all the orange nodes with the orange nodes. So there are even famous proverbs, birds of a feather flock together. So you tend to connect people which has your same feathers, your same type. Actually, and this type of homophilic association is pervasive in social networks and work organization, notably, of a large variety of types. And these, if you want a nice review, go to this annual review of sociology by McPherson and colleagues, published a few years ago. So actually, it's also something that is known to emerge, as we saw partly in the previous talk, through development and through education. So you know that already in primary schools, boys tend to play with boys and girls tend to play with girls in courtyards. And there is probably an important role, and we can discuss this later, there is probably an important contribution of education, of how we educate our children in instantiating and in setting up these homophilic behaviors. Okay, so what about gender homophily in the peer review system then? I'm showing here the probability that a woman is appointed reviewer by female editors or by male editors. You can see that through the years, there is a constant tendency, not tending to reduce nor to vary, despite the closing gender gap, for male editors to appoint less women reviewers than chance, and for female editors to appoint more female reviewers than chance. So in short, men appoint men and women appoint women. So very interestingly, this phenomenon is independent from how many women are operating in the field. So you can see actually that the disciplines like psychology, where the women editor fraction approach 40%, is actually as homophilic, is not even more homophilic than disciplines such as genetic or neuroscience, where the fraction of women author or women editors is so much lower. So there is definitely a problem of network misconstruction, of network homophilic construction that go beyond gender gap. And why should we care about it? And I'm close to the end. So you can, let's suppose that we have a social group, for instance, a group of potential reviewers, among which the competence to be able to properly review an article is graded from individuals which would be less competent to individuals which should be more competent. Let's also propose that we have two categories of reviewers, for instance, men and women, here represented by circles and squares. As a reasonable first assumption, we can assume that competence is equally distributed among the categories. Here we're speaking about science. We're not speaking about other skills that could be gender biased because of biological differences. So the task of the editor should be to identify the best reviewers for the task at hand. So for instance, let's suppose that we have to identify the top 6 reviewers for a given task. I'm coloring here the different potential men and women reviewers as a color indicating their skill level from the best, the green, to the worst, the dark red. So the top 6 reviewers that one should be appointed will be these ones, equally mixed between men and women. But now, as I've shown you, we have a homophilic tendency of selection, which means that we will tend to pick up reviewers only among half of the list. So for instance, if I am a male editor, I will tend choosing only men's, and I will get this biased top 6 selection, which you see contains some yellow and orange. So the average quality of the list that I will select is worse than the one that I will get, having a neutral non-homophilic selection. So after all, independently from political, ethical arguments, it's an economical problem. The problem is that this gender homophily affects the quality of the peer review system and then ultimately of science. Okay, so I'm at the end. So this is a reminder probably that policy makers should rethink about going beyond numeric equality. This homophily seems to be a misconstruction problem existing even when numeric equality is reached. Of course, and I hope to cover this in discussion, one should argue from where this homophily is coming. And actually, I strongly suspect that it's a problem of unconscious bias. So probably, as in the case of the previous talk, making aware the authors of the phenomenon could already tend to help. And that's something that we hope that in future publishers will try setting up. The thing is sure, this study educated myself to the importance of the topic. And since then, actually, I'm trying to build my research group in a gender homophilic way, biasing, therefore, against my intuitive bias to appoint men, trying recruiting an equal number of men and women. And I think that the behavior should change, and I think that we should really all take this unconscious bias very seriously. Then let me thank for your attention and my funders.
Thank you very much, Demian. Do we have any question from the audience? I'm also looking at the Q&A on the chat. Any question from the audience? Okay, then I'll start. How do you succeed to make this gender equality in your group? Because this is one of my issues. I already had this discussion yesterday. How do you do that? It's not, you are a mathematician. It's a field where, in average, the number of students is more dominated by male population. So how do you work to reach this balance, or to favor to have more women in your group?
Yep. Thanks very much. So So actually, in my specific domain, the interdisciplinarity helps. So I can recruit researchers from a variety of fields, from mathematics and physics, but also up to psychology or medicine. So actually, it's relatively easier. So actually, as a matter of fact, if you look at this picture, you actually have, it's not the complete group, it's just a recent group picture. Actually, the two postdocs and the PhD student that are there are all physicists, actually. So this means that independently from these different distribution across disciplines, one can find the female, the rare women, even in the field in which they are rare. Often it is a problem of short-sightedness. So we are surrounded by men and we are lazy. So I think we need an effort. So there may also be attitude differences, as we have seen in previous talks. But I think that, so the relation of selection is a directed relation. There is the tip of the arrow, but there is also the source of the arrow. I think that there is a serious problem at the source of the arrow of not taking the effort of looking the other half of the list.
Okay, it's interesting.
I have a question. I like very much the title when you say beyond numbers, because I think one point is, for me, big problem is if you set numbers, if you set a quota, it's a question you asked yesterday. So the big risk is that everybody can work with numbers in a way that fulfill the numbers. But once you have this, let's say this goal of having a, let's say 50-50 or so, how to be sure that you empower this 50% in the right way? So it's easy to have in a, let's say in a university, you say, okay, I have 50% of the whole population is women, student, young faculty, but how to be sure that you really are empowering in the same way this 50%? I don't know if I express in the right way.
Yeah. So no, yes, actually, it's a very important point. So indeed, you see actually that these, for instance, you take psychology, where you have really close to 40% of women reviewers, women editors. The homophily is very strong. Okay, so now probably we enter into the mechanisms leading to this. So one of the reasons, so historically, homophily is something that is historically the minority group tend to make homophilic choices as a way of protecting the minority group. On the contrary, the majority group tend to make homophilic choice because of, not necessarily because of an equally militant attitude of attacking the minority, but because of an habit. They are used to an epoch in which the minority didn't exist. Okay, so the mechanisms are very different. By the way, we also have in the paper, if you go to the live article, a more detailed measure that is a graded homophily coefficient between 0 and 1, actually that measure individual by individual the tendency to homophily. And actually, interestingly, across men, you have a widespread homophily, which can be more or less severe depending across the individuals. On the contrary, in women, most of the homophily is really captured by a few highly homophilic editors, which are probably what in sociology, without any negative intention, has been called femocrats, meaning persons that really try to profit of the power position that they obtained with force, with effort, to enter into the tower, into the system, and break it. So the mechanism for homophily are different. So actually, the point is that the price to pay for this strategy is that you construct actually a system that will continue to be inequilibrated. So actually, of course, I think that initially quotas are very useful to facilitate the access of women in the system, but then one should go beyond this and educate the two parts, primarily actually the former majority, to look into the other part of the network that start existing without them being aware of it.
This is a really interesting discussion. No, it's okay. So thank you, Demian. We are just in time. Thank you so much for your talk. It's inspiring, and in the same time, I think it needs reflection. So for me, for example, I will need to think more about what you have talked to us today. So yeah, thank you so much again, and I hope to meet you in person one day at KAUST or in anywhere in the world. Thank you.
I hope the same. See you this afternoon in the discussion.